All right, welcome back for part 2 of velocity versus time graphs. So we learned how to draw a velocity versus time graph from a motion map. Now we're going to draw velocity versus time graphs from position versus time graphs. So remember, my velocity versus time graph comes from the slope of my position versus time graph. So all I have to do to get my velocity versus time graph is figure out the slope of each segment of my position versus time graph. So from 0 to 1 second, my object is not moving. Its position is staying the same at 20 meters, which means my velocity in this segment is 0 meters per second. So I'm going to plot that on my graph here, and I'm going to alter my tick marks a little bit. It looks like I might need to go pretty big here, so I'm going to go up by 10, 20, 30, 40, and that's good enough, and then negative 10, negative 20, negative 30, negative 40, skadoosh. So for the first second, my velocity is 0 meters per second. From 1 second to 3 seconds, my velocity changes. It looks like my object is going 20 meters each second. How can I tell? Well, I can see that from 1 second to 2 seconds, my position increases by 20 meters. And this is in a time of 1 second. So my velocity for this segment has to be 20 meters per second. So I'm going to draw a line from 1 to 3 seconds right here at 20 meters per second. So 1, 2, 3, yep, perfect. All right, so now from 3 seconds to what looks to be, I'm going to draw a dotted line down here, to what looks to be 4.5. I'll label that nice and neatly here, 4.5 seconds. My object no longer is moving. It's at 60 meters, but it's not changing its position, which means my velocity for this segment is 0 meters per second. So from 3 seconds all the way to 4.5, my velocity is 0 meters per second. And then from 4.5 seconds to 6 seconds, my velocity changes. So if I look at my rise over run, I've got to be really careful that I'm paying attention to my time. So I'm going to do my best to do that. So my rise, I guess I should say my fall, because it's not going up, it's going down, is negative 40 meters. I'm going from 60 all the way down to 20. But my run is not a simple 1 second. I'm going from 4.5 seconds to 6 seconds. So my run is 1.5 seconds. So if I wanted to find my velocity, I'd take my displacement divided by my time. So I'm going to do that in my calculator app. Where's my calculator app? Where'd it go? Oh, right here. Nope, come on. Now my touch screen's not working. There it is. Click. Nope. Click. There it goes. Desmos. Desmos. Taking a year and a day to load. So let's see. 40 divided by 1.5 gets me 26.6666 repeating. So I'm just going to round that to 26.7. And I can't forget my negative. This is meters per second. So for the last part of my graph, I'm going to draw a neat little line. Oh, I should hit. What is going on here? Boom, shakalaka. That's what I meant to do. Hey, I think that's what I meant to do. I don't know. I'm going to draw a line for my last section here at my best approximation of negative 26.7. Something like this. That's my best approximation. So now I've got these nice segments. I'm going to start connecting them with these dotted lines to show instantaneous changes in velocity. And you can see that from a position versus time graph, I don't have to extend any of my segments. A position versus time graph accounts for all moments in time, whereas a motion map is looking at intervals of time. It's just looking at snapshots. So you have to kind of assume what's happening between snapshots. Here, I don't have to assume. I know exactly what was happening at every moment in time. So that being said, let's do one more example together. I'm going to draw a velocity versus time graph now from this position versus time graph. So let's start with this first segment. From 0 to 10 seconds, my change in position is 60 meters, and my time is 10 seconds. So my velocity here is 6 meters per second. For my next segment, it's not moving at all, which means my velocity is 0 meters per second. For my next segment, it changes quite a bit. My change in position is significant. I go from 60 to negative 40. This is a change of negative 100 meters. And this is all done in a time of, hold on, I can count. There's 5, 10, that's 15, 25 seconds. I just wanted to be sure because I made a mistake last time that I did this, if I remember correctly. So negative 100 meters in 25 seconds is a change of negative 4 meters each second. And then my last segment, I knew I changed the size of this. My last segment, my position increases by 40 meters, and it does this in 15 seconds. So my velocity is 40 out of 15, 40 meters every 15 seconds. I cannot do that in my head. I think it's going to be just under 3, but let me be sure. Oh my gosh, I forgot to exit out. Oh, wait a minute. It's going to be this with the decimal moved. Watch, 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 watch. 1.5 becomes 15. Oops, oops, oops. Yeah, see, 2.666 repeating. So yeah, that was just under 3. I'm a genius. Okay, 2.67. I'll round to 2.67 meters per second. Nice. So I have all of these velocities for my different moments in time. I'm going to start labeling the tick marks on my graph so that I have a nicely labeled velocity versus time graph that I can start plotting on. So first of all, let's focus on time. I need my time values to go all the way up to 55. So maybe I should go by 10. So 10, 20, 30, 40. Oh, it's going to be just short. 50, and then that little guy right there will be 55. It'll work. It'll work. And then for my velocity, I need to go all the way. Oh, I don't really need to worry about velocity. It's easy. So let's make that 1, 2, 3, 4, and let's make this -1, -2, -3, -4. Yes, that will work just nicely. So from 0 to 10 seconds, my velocity was 6 meters per second. Oh, shoot. I didn't label this right because that's 5. 6 is going to be all the way up here. You know what? I don't care. I'm going for it. I don't care. No one can stop me. So from 0 to 10 seconds, my velocity is very large. It's at 6 meters per second. And then from 10 seconds to 15 seconds, my velocity is very small, right here at 0. I'm going to connect that with a black dotted line to show an instantaneous change. Skadoosh. And then from 15 seconds to 40 seconds, my velocity is -4. So from 15 all the way to 40, my velocity is -4 meters per second. I'm going to connect that with a dotted line to show an instantaneous change. And then from 40 to 55, my velocity is 2.67. So I'm going to do my best to approximate that. 2.67, skadoosh, and I will connect with a dotted line. Nice. So this is my velocity versus time graph. So now I'm going to have you guys try this next one without me. Go ahead and pause the video and unpause when you're ready to check your answers. All right, I'm assuming you're ready to check your answer for this one. So for your first segment, you should have gotten a velocity of 5 meters per second. For your next segment, you should have gotten a velocity of, gosh, that's 15 out of 1.5. 15 out of 1.5 is, why do I think 10? I think it is 10. It is 10. Negative 10. Oops. Negative 10 meters per second. And then for your last segment, you should have gotten a velocity of 0 meters per second. So when we plot this on our graph, we got to mark our tick marks a little bit differently than we have in the past. I think going up by ones would be most beneficial. Oops, I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that would be 10, and the negatives will be the same as well. You get the point. And then my tick marks here, I'll also go up by 1, 2, 3, 4, 5, 6, so on and so forth. That being said, for the first 2 seconds, my velocity was at 5 meters per second. I'm going to plot that like so. For the 2 to 3.5 second window, my velocity is negative 10. So something like that. And then from 3.5 seconds to 6 seconds, my velocity is at 0. So something like that. I'm going to connect each of these segments with a dotted line. Voila. Oops. I could make that a little bit neater. Voila, beautiful. And that is my velocity versus time graph. So I'm going to stop here, conclude this for part 2 of the video lesson. You can continue on to part 3.